Alright, so this is the second video for section 10.3, the theory of equations. And since it's the second video, we're moving on to the second objective, which was to actually write the equation given the roots. So, remember, roots came from setting each factor equal to 0 and solving. Alright, they came from setting each factor equal to 0 in solving. When we do this, right, so for example, if I want to get 5 as a solution, I had to have something that would get me 5 as an answer. Well, normally we had something and then a 5 and we set it equal to 0 to solve. Well, if I want 5 as my answer, I'm going to need to add 5 over, which means I'd put the opposite thing here. So since the 5 was positive here, we'd say x minus 5 was one of the factors, because then that would cause me to add 5 over to get a positive 5 as my solution. So then if I wanted negative 6, instead of minus 6, it would be x plus 6, right? Because I'd want to subtract 6 over to get it to be 0. And all of this is equal to 0. So from before, we should have our roots. We got our roots from setting the factor equal to 0 and solving. So now we're just kind of going backwards. The factors are in the form x minus the number, where this minus really just means the opposite of whatever the sign was. Right? Because we would have had to add to move it over or subtract depending on what that sign would be. Okay, so our first step, so we're going to do our example over here and our steps over here. The first step would be to write the roots as factors, which is what we had just done. We said, okay, if the root was 5, this had to be the opposite of 5, so it was minus 5 with an x in front. If the root is negative 6, we need to have an opposite of negative 6, which is positive 6, so x plus 6 would have gotten us to that point. The one thing that you'll need to remember, which will be really big as you move on in these problems, is what happens if it's a complex number. Now, if you don't remember, complex numbers are the numbers with the I in it. And when that happens, you need to remember that you must include the conjugate. You must include the conjugate. So what I mean by that is, if I tell you that the root is 2i, it's not just 2i, it's 2i and the opposite of it, which would be negative 2i. If it was in the form 4 plus I, 4 plus I is not the only root. The other root would also be 4 minus I, because whenever we were solving with roots, we got a positive and negative whenever we got that imaginary number in there. Okay, so whenever you are given an imaginary root, you have to remember to also bring in the conjugate of that imaginary root. Now that we've got ours set up with the factors, the last step really is to simply multiply factors together to find the polynomial. So that means distributing, right? So I would do x times x, which is x squared. X times positive 6 is positive 6x. Negative 5 times x would be negative 5x. Sorry, my pen was running out of ink there. Negative 5 times positive 6, which is negative 30, equals 0. And then we would need to just combine our like terms in order to get this to the end. So positive 6 minus 5x would be a positive 1x. We still have our x squared out front, the negative 30 in the back, equals 0. And normally we wouldn't write the coefficient of 1, so my final answer would be x squared plus x minus 30 equals 0. Okay, so let's do a couple more examples together. So let's look at example number 2. This one has that complex number in it. So you need to remember that 4i is not the only root. Our roots are actually 4i and negative 4i, because we need to take the conjugate into consideration. So when I go to write my roots as factors, it would be x minus 4i to get my positive, and since this is negative, we would say x plus 4i to get to that solution equals 0. And then it's distributing like normal, but you're going to have to remember to think about how these i's affect things. So x times x is x squared. X times positive 4i would be positive 4i, negative or positive 4ix. Negative 4i times x would be negative 4ix. Negative 4i times positive 4i. Now this one's the one you have to be careful with, right? So you're going to do negative 4 times positive 4, which is negative 16. And you also have to consider that you're doing I times I, right, which is I squared equals 0. So when you first look at this, most of you will say, oh, well, these are going to cancel each other out, giving me x squared minus 16i squared equals 0, which is great. But this is not your final answer. You need to remember that I squared actually means negative 1. So this is really x squared minus 16 times negative 1 equals 0. And negative 16 times negative 1 would be positive 16. So we have x squared plus 16 equals 0 as your final polynomial. So remember, whenever you get an I squared, that you have to change that to a negative 1. All right, example 3. So we have a root of 4. We have a root of 4, so that's just going to stay 4. But again, we have a complex number here with that imaginary piece. So we need to realize that it's not just 3 plus I. We also have a root of 3 minus I, as well as that negative 4 from the front. So this time we actually have 3 roots, which makes this a little bit more complicated, but still achievable. So in order to get negative 4, it'd be x plus 4, because we do the opposite of the negative. Now when we go to do these types of problems here, okay, they're a little bit different. We're still going to do minus here, but when you do this, I actually like to make a square bracket. Actually, I'll do the square bracket later. We'll leave this a parenthesis. So it'd be x minus, and then we're not just minusing one of these, we're minusing this entire piece. So since we're minusing that entire number, the 3 plus I, we're going to put that in square brackets. So now when I go to do the next one again, since this isn't just a single term, it's going to be x minus, and again, it is all of that I'm going to put in there. So 3 minus I equals 0. Now, when I look at this, I actually ignore this x plus 4 first, and I focus on my conjugates to begin with. So I'm actually going to cover that up for right now and completely ignore it and just focus on multiplying these 2 sets of parentheses, because you're going to have to multiply one set of parentheses, and then whatever that answer is, you're going to have to multiply by the other set of parentheses. So let's focus on this piece first. So I want to get, the thing that confuses me when I look at this is we have parentheses inside of parentheses. So instead of multiplying all of it right now, I'm just going to get rid of these parentheses on the inside first by distributing that negative inside, which would give me x minus 3 minus I in the first set of parentheses, and do that same thing here. So we end up with x minus 3 plus I in the second set of parentheses. And we probably need to make sure we bring this down as we go along. And now when I go to multiply this out, I'm going to ignore that x plus 4, and I'm just going to distribute out my complex numbers first. So x times x would give me x squared. X times negative 3 would be negative 3x. X times positive I would be positive xi. Then I'm going to move on to do the next one. So I will now do negative 3 times x, which would be negative 3x. So I'm going to put that underneath the like term to make it easier to combine like terms later. Then negative 3 times negative 3 is positive 9. There's no like term to that, so I'll put that on the outside. And negative 3 times I is negative 3i. Again, there's no like term to that, so I'll just put that at the end. And then I'm going to do the same thing with the last term. So now I need to distribute my negative I out. So negative I times x would be negative xi, so I can put that under the xi from before. Negative I times negative 3 would be positive 3i, so I can put that under this one. negative I times positive I would be negative I squared. And now I can go ahead and combine things together to see what we've got left at this point. So there is nothing to combine my x squared with, so I'll just bring my x squared down. Negative 3x and negative 3x are going to combine to give me negative 6x. Positive xi and negative xi just cancel each other out. The positive 9 can go ahead and get brought down since there's nothing to combine that with. My negative 3i and positive 3i cancel out, leaving me with a minus I squared. Now before I even bring that down, I know I squared is actually negative 1, so I'm doing minus a negative 1, which is actually a plus 1. So now I can go ahead and combine my like terms, and I have a trinomial again. So x squared plus 6x plus 10. And then don't forget that we had that x plus 4 to bring down. Now I need to distribute this out, and then I'll be done. But by multiplying this out first, we were able to eliminate a lot of terms to get it back down to a trinomial, making it easier to distribute out again. Okay, so now we're going to distribute our x in. So x times x squared would be x to the third. X times negative 6x is negative 6x squared. X times positive 10 would be positive 10x. Negative 4 times x squared is negative 4x squared. And again, I like to just line up my like terms to make it easier when I combine them later. Negative or positive 4 times negative 6x would be negative 24x. And positive 4 times positive 10 would be positive 40. So now I can go ahead and combine my like terms here to say that we've got our x cubed, negative 10x squared, minus 14x plus 40 equals 0 is my original polynomial. All right, so you have 4 problems to try in the back before you come into class tomorrow. So don't forget to do those.